Alright, so welcome back. Howdy, we have another question here. This is regarding the longest palindromic subsequence. So I've seen this question before. This is an interesting one. I actually don't know what the answer to this one is. I guess we'll get right into it because I was thinking about this one too, and I kind of got stuck. I don't actually know. This question is a little bit more involved. It's there is something here which is like, okay, so it's a really straightforward question, simple, straightforward question, right? Subsequence. Oh, excuse me. I thought this was consecutive palindromic subsequence, or palindromic consecutive sequence. A subsequence is not actually. Oh, that's interesting. This actually might be not as hard as I thought. I kind of misunderstood the question. If it was a longest palindromic consecutive subsequence, that's an interesting question. I think you could do a dynamic programming solution potentially, but it's a bit challenging. I guess it's maybe linear. I was trying to figure that one out. I was trying to think of that. Like maybe you can do the longest palindromic subsequence that begins at index 0, and then the one that begins in index 1 and index 2, index 3, etc. And I think they might be related to each other, each of those sort of subsections of the problem. Yeah, well, I guess the longest palindromic sequence at index 1 would be related to the longest palindromic sequence at index 0, because index 0 should be basically the sequence at 1 flanked by 2 characters. Or, yeah, well, I don't know. I'm not sure what the relationship would be. That's kind of where my thinking was. I got kind of stuck on that. But this actually, the longest palindromic subsequence means you can remove characters if you need to, but you don't change the order of the elements left over. So, this is really interesting because I think you need to use a stack to solve this one. I think you do it in linear time with a stack, but I'm really not sure. Actually, this is like a really good question. My thinking is, I think I may have actually solved this already. I've seen this problem before. So my thinking is, I don't know, actually, I don't know the solution. I guess you see the first character. So I guess you could do the same thing we just did. I was just describing, where you say, okay, let's try. So yeah, let's try. So okay. So the previous, what I was just describing about the consecutive palindromic subsequence is, it could be done in quadratic time because there's a quadratic number of consecutive subsequences. However, the total number of subsequences period in this string is exponential, right? You either have for each character exponential in the size of the string. So you can either the subsequence contains the character at a particular index I, or it doesn't, right? And every possibility can be explored through there, which gives you 2 raised to the size of the string, which is exponential, which is the number of possibilities. However, the longest palindromic subsequence, so the number of palindromic subsequences could be also exponential, but the number of palindromic subsequences is probably there aren't that many. I wonder if you can do. Yeah, I wonder if you could do this in quadratic. Let's see. What are the bounds on the string size? 1,000. Okay. So you can do this in quadratic time, and it would be efficient enough. If you could do this in quadratic time, it would be sort of efficient enough, which I think you can. I think you can actually do Yeah, dynamic programming solution for this, that'll be quadratic. So it would look something like this. Yeah, let's try it. Let's try it. It's going to be, hi, do you have a practice problem list on recursion problems for C++? Hello, Venjot, Venot or Venjot? Hello, Venjot. Ignis. That's a name that's going to be difficult for me to pronounce. I think it's like Northern European. Venjot Ignis. Forgive me if I mispronounce that. Do I have a practice problem list on recursion problems with C++? I don't. Actually, I've just solved them like a lot, I guess. I've just solved a bunch online. I mean, there are problems on LeetCode that are pretty good. But recursive problems are actually not that challenging, believe it or not. The idea, so there's a couple things. So right, there's you can go on LeetCode and actually search for recursion problems, right? I think they have. Go to problems, and we go to expand. Where is it? And recursion. I have to be careful though, because recursion and depth first search questions tend to be like the same. So yeah, you can look up depth first search questions. You can do trying to find something that's like strictly recursion or mostly recursion. I don't know what a rolling hash is. That's new to me. Binary index tree, segment tree. These are kind of these would be hard for me because I don't really have a lot of practice with that. Memoization probably would be also recursion potentially, not necessarily, but potentially. Divide and conquer usually is recursion. So you can do divide and conquer, you can do depth first search, recursion, there you go. Yeah, so you have different subjects. So DFS, recursion, and divide and conquer, all three of these would give you some practice problems for, what was I saying, for recursion, if you needed that. Backtracking also is a good one. So there's a difference between recursion and backtracking. That's kind of the thing I wanted to say. And dynamic programming also, like they're all related to each other in some ways, but they're all different. So backtracking, depth first search, dynamic programming, and recursion they all have elements that are similar, but they are each somewhat distinct from each other, and that's like a kind of a subtle thing, kind of a nuanced thing. So while backtracking is technically recursion, it's a very different kind of recursion. Backtracking actually is pretty much depth first search, except depth first search typically is over a graph, whereas backtracking usually is over a set that's it's like a very large graph, basically. So like the set of possibilities, of all possibilities. Like for instance, what we're actually looking at right now would be like the set of all possible subsequences. Probably would be considered more of a backtracking question than it is a depth first search, even though technically there is a graph that you could imagine from where each node is each subsequence, and then there's a connection between nodes if you can get from one subsequent sequence to the next by adding or subtracting a character, adding or deleting one of the characters from the original string. Basically, backtracking and depth first search are effectively the same thing. They're just, I think backtracking usually is over just like a much larger set, I guess, of things. Now, what makes it depth first search, backtracking, and dynamic programming and recursion. So usually you use recursion when you backtrack or you use your depth first search, but you don't necessarily need to do graph traversal using recursion, and actually even a lot of recursion itself, you don't necessarily need to use recursion because you can use a stack and basically emulate the call stack, and you iterate through your problem that way, which is kind of complicated, and you're probably better off just using recursion. Compilers are, well, yeah, no, actually, you're probably just better off using recursion in that case. Yeah, actually emulating the stack itself is like kind of challenging, I think, in my opinion. I've tried it in the past. It's like it's kind of difficult. What makes dynamic programming special compared to depth first search and backtracking and recursion is that also you actually, so a couple things. So the problems that you work on, the problem that you solve with a depth first search or backtracking, you may actually visit the same node multiple times. That's probably the way to think about it. And in that case, you may be able to save the solution found for that particular node, and instead of walking the subgraph or the subtree from that node, you can just return the value directly, and so you can save some work. And for certain problems that actually saves so much work that it takes you from exponential time algorithms to polynomial time, to quadratic or polynomial, which is a lot faster. So that's what the key difference between dynamic programming problems and depth first search, backtracking, recursion problems is that the dynamic programming problems, basically you are revisiting certain nodes so many times that it's actually better to just save the answer and immediately return it rather than calculate that same one over and over. So you eliminate a lot of redundant work. One more thing about that to note is that dynamic programming questions, not only can you think of them like, sort of a graph traversal that you're revisiting the same node, you can actually restructure the approach to the problem so that way you can conserve memory. So instead of having a sort of thinking of it as a graph traversal, you can actually have it sort of almost like a tree, if you can imagine like a tree traversal, and you can actually go backwards up the tree instead of going down through the tree. And then you can have the bottom layer of the tree be the only amount of memory that you use. So instead of a whole two-dimensional matrix to represent your graph, or have a huge memoized hash map that's two-dimensional hash map of stuff, you can have just one vector of the bottommost tree, and then also you can process each layer of the tree one at a time. So that way you're actually just doing a vector. Like you have linear amount of memory if you do it that way, and it's the same. Probably not the same running time, but same probably asymptotic running time. It's similar. It's basically the same idea, but it's sort of a restructuring of how you actually approach the problem. And so dynamic programming problems, you can actually take what would be sort of a top-down depth first search problem with what you call memoization, where you return your solutions immediately, and that would sort of create like a tree with certain, or a DAG, actually not really a tree, it's a directed acyclic graph where some pointers are returning the same node over and over. You can actually go backwards up the tree as a vector, and that would give you a dynamic programming approach. That's typically when people talk about dynamic programming, they really mean that. They usually don't mean a memoized depth first search. They usually mean a sort of a vector that gets modified at each step, and you can conserve memory, and it's a lot more efficient because it's really efficient because you've allocated all the memory. Also because usually it's iterative too, instead of recursive. So yeah, that's something personally I've been kind of recently been challenged by, is like, how do I easily go from like a simple depth first search that's been memoized to a dynamic programming solution where that's a lot cleaner and a lot simpler to understand and a lot more efficient, or just somewhat more efficient. It's not asymptotically much more efficient, but it's more efficient, like I guess on the cases that you might see in LeetCode. Also, I did a lot of talking without reading what you had to say, so forgive me for that. But yeah, I would say you can go on LeetCode and grab some of these problems. These are pretty good. So dynamic programming, depth first search, backtracking, and recursion, and memoization, all those are related to recursion. All those are, solid questions to work on. There's a few hundred. Apart from competitive programming, what is the future of C++? I think I am getting too much into the details of C++, like STL and stuff, and don't feel like it's going to help me in other fields like ML. Apart from competitive programming, well, C++ has a ton of applications. I mean, you can look up C++ jobs. Like if you just go Stack Overflow. Well, okay, so I think I'll explain it this way. Literally every system that's like a serious system, I guess. Or, not I shouldn't say serious system. Like, I don't know. It's like pretty certain, like, I guess is ubiquitous or like really extremely popular, or like has a lot of attention and resources and things like that. So like I'll say like your browser, for instance, is probably written in C++. I think most of them, just about all of them are. But like the browser is written in C++, right? Your operating system is written, probably the kernel is written in C usually, I think, and then C++ it would be like all the other programs. Like an email client on your desktop would probably be C++. Like OBS is probably C++, the thing that I'm using right now. Let's see what else. Probably all of these programs I have down here were written in C++. Basically everything is written in C++. Not everything, but every like core system, I want to say, is written in C++ for the most part. So like pretty much everything has C++ in it somewhere. And actually most code and most C++ is actually written for embedded devices. So for instance, like your remote controller in your, I think it's C++. It's either C or C++. Your remote controller would have some code embedded in that system that would, more likely than not, was written in C++. Also, like your router, for instance, I think is like that would have C++ code for for its hardware, sort of the software for the hardware, and basically, yeah. So like that's actually most code is embedded system. Most things are embedded system. I think most of the code that exists is in embedded systems, and most of that's C++. But if you want to work on operating systems, you would want to know C++. If you want to work on browsers, you would want to know C++. If you'd want to work on desktop applications, of which there are different varieties and types and kinds. For instance, there are firms that will pay you very large sums of money to help work on their algorithmic trading systems, right? Firms, hedge funds, and things that have managing huge amounts of money. They pay quite a considerable sum for trading systems. That's actually my current employment. I work on one of those systems, and although I don't want to mislead you. I was hired and vetted as a C++ developer, but I actually don't write a lot of C++ code at my job. One of the reasons why I do these streams is because I'm trying to like make sure my skills don't kind of fall away. Yeah, so there's that. I don't know. I mean, C++ is sort of like it's one of those languages that like it's really, I don't know. I mean, it's up to you, whatever you want to do. Like, I don't know how great it is in terms of employment. In other words, like if you wanted to get something that pays well quickly, probably you're better off learning web development, just because there's really high demand for that. Where web development is, web servers will be built in C++ usually. Also, all these things, also Java can be used as well. I'm sorry, not everything is done in C++. You have a lot of things in Java as well. But yeah, back-end systems, basically, you would have back-end systems can be done in C++. There's other languages and things too. I mean, it's not like the only thing you can use in C++, but it's usually Java and C++ are kind of like the core languages that are used for like really serious systems, or not serious, like I keep using the word serious, large and significant systems. We'll just say. That would be the core large, significant core systems. I'm thinking what are some other things. By the way, I think machine learning, a lot of places seem to want to use Python for their machine learning things. There's different libraries and things. I'm not a machine learning expert, I guess, so I'm probably not the best person to ask about that, but I'm just aware that like if you want to get into machine learning, apparently Python's a good language to learn. Although Python is interesting because it's kind of not that hard to learn. It's actually like kind of made to be relatively straightforward to pick up. It definitely has a lot of nuance to it, but like C++ as a language, in my opinion, is like extremely broad in terms of like how many things you can the amount to learn about C++ is really a lot. There's a lot that can be learned. Yeah. Obviously, there's a ton of stuff that overlaps with other languages because programming in general has certain principles and sort of certain knowledge base that is generalizable to all of the languages you might use and all the things you might do. But C++ does have a lot of like specific to C++ things. A lot, really a lot. But what else do I want to say? Yeah, the future of C++. I don't really know. It's quite happy about C++ WebAssembly, C++ to rule the web dev space, but the project has not gained much traction in the job industry. Yeah, I think I heard about that. I don't know, what is that again? I don't remember. And I have a habit of just putting CPP ref in front of everything. WebAssembly. I think I've heard about the WebAssembly. Pass arrays to C++, WebAssembly will work in C++. I don't actually know what it does. I think the idea is that you can use, instead of using JavaScript, you can use C++ for the front end, basically. Or not basically, but for the front end. But I don't actually know. What's this? WebAssembly and LLVM. I don't actually know what this does. I don't know if this is used to compile a browser. LLVM, I know what that is. Excuse me, that's a compiler toolchain to basically build compilers for like if you want to write your own language, you can build a compiler for it. I think LLVM is used also for the CLang compiler for C++. There's that as well, which I like to use. Now I have recent. It's pretty recent I've done this, but now I have oops. Yeah, there it is. I have oops. Can I do this? I have GCC. I have Cygwin installed on this computer with GCC installed, and so I have a yeah. So I've been like kind of using that to compile like test programs on my computer because I don't really like using Visual Studio Code or Visual Studio. It's kind of a nuisance. I think the problem with web development and like C++ is that the JavaScript sort of libraries and community is like enormous, and you kind of would have to port all the JavaScript libraries to C++. That's I'm assuming that's what the WebAssembly is supposed to do. It's supposed to basically allow you to build the front end in C++ rather than JavaScript. I think it's just you'd have to port everything from JavaScript to I don't actually know what it does. I'm not familiar with it. Maybe I can find out like what is WebAssembly. Let's try that. But no, you wouldn't primarily use. Actually, I like the MDN. I like Mozilla Developer Network. I like this. New type of code that can be run in modern web browsers, low-level assembly like language, compact binary format that runs with near-native performance and provides languages such as C, C++, C#, and Rust with a compilation target so that they can run on the web. It is also designed to run alongside JavaScript. Oh, okay, there you go. Yeah, wow, that's awesome. Cool. Yeah, I like that. I'm not super familiar, but yeah, I think I don't know. Not that you would need to compile all the JavaScript libraries, but I don't know. Like I guess you basically have to tell web developers to become C++ developers too. I think that's kind of what this comes down to, which they're not. Like they're just not. It's two different worlds, like totally different worlds. Like I said, C++ is primarily back end, JavaScript is primarily front end. Not that there isn't crossover, but usually what happens with people who are familiar with JavaScript is that they get familiar with JavaScript, they become a front end developer, and they learn all kinds of JavaScript libraries, and they learn how to build like sort of the front end for web applications, and probably more likely they actually become employees at large companies and help basically nurture and maintain and build out their their websites, their front ends. I guess, I assume. I'm not actually a front end guy, so I'm just kind of assuming this stuff. But you'd have to you'd need like full stack developers probably to get this going, and like that's kind of a rare breed because they have to be both a back end proficient, fairly proficient at back end and fairly proficient at front end, and be able to sort of combine that. Then they would have the skills to actually be able to bring the back end sort of language and I guess approach to the front end too, something like that. I don't know. Like there is such a thing as like division along language knowledge. Like it's JavaScript and C++ are not the same thing. They're just not. Not that there isn't crossover, but you would have to significantly learn about C++. But yeah, I think probably it's just like I said, it's probably just like efficiency and like. Why would someone who's a front-end developer want to learn C++ and vice versa? Why would someone who knows C++ bother to learn, not just to learn JavaScript, but actually be working on the front end? You kind of need full-stack developers to like really pick up. So I think this could be good, but probably won't be super impactful for a long time. But really interesting. I like that. Really cool. I like that a lot. Can kind of have whatever language you want in the browser. Yeah, I think another issue too is like you have to work with other people. So like if you want to hire JavaScript developers or front end developers, and most front end developers are JavaScript developers because most front ends are written in JavaScript, then if you start writing things in C++, not only do you have to hire someone who does, and let's say like the guy who does that leaves or something or whatever, something happens where you got to hire somebody who knows C++ and JavaScript. Like you're gonna have a much harder time finding that. So I think it's just like the ecosystem. There's a lot of like momentum that like this would really struggle. So it definitely flows against the tide. I think in terms of like I guess the ecosystem, something like that. Hopefully that makes sense. Okay, so neat. All right, fair enough. No, I wouldn't recommend learning C++ in the hopes of using Linux for the win. Yeah, man. How do you like that? I have a Windows machine that I'm using Linux on. Heck yeah. Yep, that's right. I actually kind of want to stop using Windows altogether if I can help it. I just really don't like Windows. It's not even the Windows operating system that I'm that frustrated about. It's more so although there are things about the Windows operating system to complain about, but I'm actually just angry. I'm like literally frustrated that like it's kind of like ridiculous, but I'm frustrated that Bill Gates is not a Christian. If you can imagine that, like it seems like a very bizarre thing to be frustrated about as a software developer, but basically because Bill Gates is not a Christian, he's an unrepentant sinner that's going to hell, and everything he does is corrupted by sin. So giving him like this massive influence through Microsoft basically creates this like corrupt ecosystem that like the whole world is now tapped into, and it's not good. It's not good. Yeah, I don't want to go into too much detail on that, but like yeah, I like Linux because it's free and open source. Basically, you could do whatever you want with it. Like you're like using it doesn't mean you're contributing to some corrupt person's plans, right? Like just using Microsoft, like they might be taking data you don't know about. They might be actually like something really creepy was I installed Windows on another machine, and it actually realized who I was, and actually my desktop background on my laptop got somehow transferred to this other machine, and I was like really creeped out, and I was like, okay, so I don't know what's going on here, but like Windows has got some funky thing going on where it knows who I am, and like that's not even a thing with Linux, because Linux is not a company. Like Linux is just an operating system, whereas the Microsoft Windows operating system, like you're not using an operating system, you're like hooking into a company, and you're getting and they're hooking into you. Like your soul is getting touched. Just kidding. I wouldn't say your kind of, maybe, I don't know if that's actually too far from the truth, that your soul is getting somewhat fused with Bill Gates, and it's like, I don't want that. Yeah. So that doesn't sound like a trip to you. Doesn't sound like kind of crazy. Yeah, like I said, I kind of want to go too far into that because it gets a little bit. It's like a spiritual thing, but I'm not. Yeah, I'm not up for it. I'm not a fan of Apple. Not a fan of Windows. Because they're corporations, not operating systems. And using any of their products, you're getting latched into their corporation, and it's like, unless it's a Christian organization and they're repentant and they're trying to do right by God and they're trying to be morally upright and all those things, and not just morally upright like we try to do the right thing, like no, morally upright as in I don't want to fall in the hands of a living God that's going to send me to hell for all of eternity kind of commitment to trying to do the right thing. Yeah, other than that, I just use Linux. And yeah, and Linux is a lot more lightweight. Like I could just press a button and then boom, I got to I can compile something. I think it's this program is the. Also, I don't know if you can hear that. I don't think you can hear that. Hopefully you can hear that. I have that. Oh wait, can you? You might be able to. Yeah. That'll get annoying. I'm gonna turn that off. I forgot about that. Is it this one? Yeah, I think it's this one. So now, like, how quickly I can compile this and run it. I just click a few buttons and I have a compiler at the ready. Whereas, like with Microsoft, I guess Visual Studio Code, technically you can kind of do that, but I've never actually done it. And then Visual Studio, you have to like open up Visual Studio and like it's like a whole to do, and then there's like a project file. Like there's actually this like extra level of structure involved with your file system, which is like so unnecessary because all you need to do is link your compilation units together. That's it. Link your, what do they call that? Translation units. So all you have to do is link your translation units and you have a program. Like you just have a compiler and a linker. Like that's all you need. You don't need all this extra stuff that Microsoft gives you, and it's just kind of frustrating. Anyway, okay. So yeah, to get back to the problem. So so what was your question? Why are you still on Windows? What specific applications are you attached to which do not allow you to leave Windows environment? Oh, there you go. Yeah, fair enough. I have a job that they use Windows, and the customers use Windows. So for the most part, actually, I can't say that, but I'll just say some customers use Linux and some customers use Windows. But there's enough customers that use Windows that there's a Windows application, and I basically have to use Windows because that's what my employer provides me with as far as like the machine they want me to work on, and then also the application itself that the customers are using is Windows for the most part. So kind of just need to. The other reason too is that Windows is a lot fast. So like there's a few other reasons. So there's that, which there's that. Then there was a girl that I liked that was a streamer that played video games. She played Fortnite. Fortnite was only available for Windows because Windows is popular, a lot of games are built for Windows. So if you're like a gamer, you probably would have Windows. And so I got the Windows machine so that I could play with her, playing the game she liked to play that was only for Windows. And it was also a lot faster to set up the machine with Windows rather than I was going to use Arch Linux. I had set it up with Arch Linux and I was going to do like a dual boot with Windows and Arch Linux, but I realized like I'm just a lot more familiar with Windows because I used it since I was a kid, and also it was really fast to set up. So I don't know. I guess that's yes, but I'm no longer pursuing that woman. And I think I'm not going to pursue any woman for a while. I need a break. I just need a break. But that was one reason, is that it was like very specific. Like I needed Windows to play a video game. Which is weird. It's really weird. But then That's not a thing anymore. It's probably, I don't anticipate that for a while. So I guess that was a thing. And then the other issue is like it is in some cases faster to set up things with Windows. Like if you want, like there's a lot of programs that are just kind of out of the box with Windows that you can just download it and get it going. Whereas on Linux, like you have to kind of download everything. Well, again, I guess it depends on the kind of Linux you're using. Like I'm kind of like, I would use Arch Linux, and I would, every program I would have to like. I think the issue for me is more so that like I think I would have to familiarize myself with each program, and I just don't want to, I suppose, because just overhead. Time to do that, but I actually do intend at some point. I'm kind of in the midst of things in my life where I'm like, I don't know, my priorities are kind of all over the place, and I'm very preoccupied. But once I get things going, I do want to take that machine, remove Windows from it, and go back to Linux, go back to Arch Linux. Yeah. Have you heard about Windows 365? Windows now comes in a browser. I guess now there's no need to be on Windows, rather use Windows from a browser on Linux. That's hysterical. Windows in a browser. That's so funny. Yeah, I would use that actually. If I could, that's pretty funny. I don't know. I definitely would want to go. Yeah, I definitely would want to go to Linux, and then I probably would want to. I probably would use the browser Windows. That's so weird. I guess I would use browser-based Windows, and then use that to RDP into my work machine. Windows 365 is a new launch by Microsoft. I don't know, but like I said, I don't know if I trust Microsoft though. That's like actually the main impetus that I don't want to use Windows anymore. Is that I'm just like that, and like I said, it's using Linux gives you like so much less overhead that like I just really appreciate it. But that's kind of funny. They're gonna launch it from the browser. That's interesting. I don't know, man. I don't want Windows on any of my machines. Like I just want Microsoft. I don't want Microsoft anything anywhere. Like I just want to. I kind of want to like almost quit software development too, as like professionally. I kind of just want to do it. Like I don't know. I don't know what I want to do, but I just like not be beholden to any corporation regarding software. Like that's something. It really does bother me like a lot that like software is so dominated by corporations. Because it really doesn't have to be. I mean, it's almost like your calculator would be like dominated by a mega corporation. It's like it's just a calculator. Like why this like I guess part of that is like you can't. Most people don't build their own calculators, but like it's not like you couldn't. It's not like it's that astounding of technology that's like you couldn't build certain pieces. I guess I don't know. I don't know. There's this part of me that's like has this almost fantasy of like people who could, you sort of have a manufacturing plants that would send you parts of a computer or something, and you can just build your own computer, and then like you can write your own software or get online software, which is kind of what the PC was, I guess, way back when, and like it's kind of what Linux is like, sort of. I don't know. Sorry, I'm kind of rambling off topic now, but I don't know. It irks me. It irks me to think about like massive corporations because you don't know what they're getting up to. Like there's this. No, I don't know if I want to get into that. It's kind of a controversial thing, but like the idea of like, hey, wouldn't Microsoft be interested in being one of the first people or to corner the market regarding genetic programming, like literally programming someone's genes? In other words, injecting you with stuff that reprograms your genes. And then it makes you kind of wonder. It's like, well, Microsoft has been like really involved with pushing vaccines. I wonder. And then you think about Google too. It's like Google and YouTube. I totally forgot about them. They don't even have an operating system, but they're like, they dominate the web. They dominate the web browsers and searching and things. And they kind of get into all kinds of other stuff too. And like, I just don't like the idea of like tech companies getting involved in like massive geopolitical movements and massive I don't know, political efforts and things. Just like really It's like they're just calculators. What? It's almost like, why is my calculator telling me what to do? Like it's kind of the position I find myself in. I'm rambling on now, but yeah, probably it's interesting that you could put it in the browser. That's definitely peculiar, but I don't know if that's for me. I don't think so. I might be interested in doing that just to remote into my work machines. Have you heard about Google Project R way back in 2014? Corporations don't want the world to be customizable, rather they want to serve their pre-choices to us. Have you heard about Google Project Era or way back in 2014? Corporations don't want the world to be customizable, rather they want to serve their pre-choices to us. Google Project Ara. Oh, it's Ara. Oh, I see. 7 years ago, I guess they had a. Interesting. I don't know what that is. I have to look into that. But by the way, I would say what you just suggested isn't necessarily a nefarious thing. Like if you're familiar with it at all, like it's a very like I don't know. It's like it's not like a. It's just something in real estate that exists. So if you're familiar at all with this, basically you can buy a plot of land and build a house, and you could hire the builders yourself, or you could build it yourself, or you can get like somewhat pre-built plans, like pre-made plans that have already been sort of made, and you just have someone build it, or you can even have like, excuse me, yeah, you can have or builders who are familiar with those kinds of things. They only build that, I guess, and build it for you, or you can actually get pre-built houses, or part of a pre-built house and get that placed, or you can slightly customize your plan. It's like a pre-built, for the most part, predetermined plan with a few customizations. There's like a lot of different options, but like there are options where like there's less and less customizability, but there's some degree of efficiency there because you already know what it's going to be. People who are sort of familiar with those plans can build them quickly, and they're familiar with them, and so they could do it cheaper, they could do it faster. Some places actually only want you to build like a sort of a pre-built plan. So there is some impetus. There's a trade-off there of like freedom and efficiency that very large corporations definitely would prefer to have the efficiency part. And like this is coming from me personally. I have some experience with like customer service. Quite a bit. Actually, that's my job. This is a customer service role, really, among other things. And actually having like a predefined preset system that I'm very familiar with, and like it's like sort of like we give the client options, and then like that's what they have to pick from, as opposed to like customizing every little detail. Is a lot easier to maintain from a support perspective, because everything that's customized has to be maintained, and the person who customizes it may or may not be the one maintaining it, which means now you have to train somebody else on this customized piece to be able to fix it, to maintain it. So it's sort of like that concept of like replaceable parts, right? Like if all the parts are replaceable and you can build them anywhere, then it's a lot easier for some mechanic down the street to handle whatever problem you have, because they're familiar with this sort of pre-specified item you're looking at. Whereas if it's something that's totally customized by somebody, then when you take it to someone to look at it, to handle it, it's just like, who made this? How did they make it? Like, I don't know how to fix this, that kind of thing. You can look up the first video on YouTube, Google Project Ara. Google was so ahead of its time, it was like Tesla of the 2014 era. Gotcha. Yeah, I could look it up. I'll hold off for now, but that's really interesting. Yeah, that doesn't surprise me at all. I have to say, personally, I wouldn't say that's like the most. It's an insightful thing, but it's not like the most incredibly insightful thing. As I said, like it's actually that concept of like trying to kind of like narrow down the options that people have, or that your customers have, so that it's easier to support them. That's actually like kind of goes way back. Like I said, replaceable parts is like, however long ago that goes back. So yeah, I mean, I can kind of see that. Like that's not necessarily a nefarious thing from corporations. However, what is nefarious is like companies like Google and Microsoft and like all these tech companies, in some sense, don't technically need to exist, because you can write the software and you can make it free. Like it doesn't actually need to be developed professionally. And I would even argue like there's a lot of efficiency problems with developing software professionally anyway. So it's kind of like it's not like it's really that beneficial to do it the model that's been used. So I don't know. I don't know. I just kind of we're not there yet where we can just like make all software free and just like kind of be done with software development as a profession, which I think would actually be good. Actually, I think that would actually be a good thing overall. Because like I said, I kind of just wonder why pay for this stuff? Like why? like why not just build your own computer, pay for the pieces, put it together, and then put your own operating system on there, and then boom, you know. And I don't know. I don't want to get too far. I get it. People should get paid for their labor. I get that, but also like a lot of the stuff for the most part, you can either build it yourself or download it yourself, and it's and from someone who's already built it, and it's free. So anyway, let me not get too far into that, but yeah, it's interesting stuff. What companies have done and have gotten up to and all that. But by the way, all these things I'm suggesting are pretty like utopian, idealized. Like they're probably not necessarily practical. I don't necessarily know what's going to happen or what should happen and all of that. Yeah, I think everybody should worship God. Everyone should turn to Christ. And wouldn't that be a wonderful world? However, we know from Scripture that that's not how it works. Like 99.9%, even 90, I'd say like 90% of people who call themselves Christian are not going to heaven. So yeah, there's that. Let me get back to the problem if you don't mind. I appreciate your questions though. I appreciate talking about this stuff. It's fun. It's interesting. But yeah, so find the longest palindromic subsequence length in S. Okay, so the thing about this is that we can actually iterate over. We can do a recursive program, and iterate over all of the subsequences, right? And try to find the longest one that's also palindromic. So we're just going to write a routine. So let's try that first. Let's see if we can do that. So that'll be a DFS. And the thing I want to do with that is I actually want to. I think I can use dynamic programming there somehow to optimize this algorithm. That's kind of what I'm thinking. It's kind of what I'm looking for. So let's see if we can do that. It was nice talking to you, William. Yeah, it was good talking to you too as well, Venjot. I appreciate it. Thank you for coming by. I appreciate it. So let's see if we can see how we do here. I don't actually know. I'm going to come up with just like a brute force solution because I have an idea of what we can do, but I don't necessarily know. So, okay, so we have two options at each index. You have either include that character in the subsequence or not. And we also can check if this particular subsequence is palindromic. We can write a subroutine to do that. Okay. We're going to use integers. So we'll do, we can use a vector of integers. We can actually do like, I'm trying to think how to do this. We can do, how about this? Let's do it would be a bit set, but a vector of bools the size of, call this state. And we're going to say s.size, and all be false initially. And we're going to take the state, we're not going to modify this. We'll just call this, we'll call it v. And we're going to say so the vector, we're going to convert it to a string and tell whether or not we are palindromic. And basically we're going to iterate from, we have 2 pointers left and right until we see something that says true on both sides. And then if if the string at that index where it's true, that says true, if those characters match, then we continue. If not, we return false. So yeah, kind of an interesting way to do this, but we're going to say, really it's going to be a while. So we'll do int left equals 0, right equals s dot size minus 1. Say while v of left is, well, it's not true, we're going to increment left and then while not v right, decrement right, and you also need to say left is less than right, and or less than or equal to, and same thing, left is less than or equal to right. Yeah, and then you're going to say while, so you do that first. So it's going to be like a do until, I guess. You could even do like another while loop here. So return true if we get all the way through it, but if we get left and right and we say if, so this is kind of an interesting way to do this, but we'll say if s of right is not equal to s of left, then return false. Okay. I don't know if this is the best way to do this. Yeah, definitely not. How are we doing? 50 minutes. Okay, I haven't really looked at the problem. I just kind of rambled on not rambled, but I talked about a bunch of different things, which is fine. But well, anyway, we have 15 minutes of not talking about the problem, which is okay. So this is what I'm going to try to do, and we'll say left, right. While left is less than or equal to right, then we can say we're going to say increment left until it's true, and increment right until it's true, or they're equal to each other. While they're equal to each other, right? We'll say if. Also, we need to have an if here. If left is less than or equal to right, and these are not equal to each other, then return false. So if at any point you scroll from left to right until left is true, and scroll from right to left until right is true, and then if these are not equal to each other, you return false. Rather the part of the string that's being used there, those two characters are not equal to each other, return false. If at every left and right sort of shift they are equal to each other, then eventually you're going to get left is past right, and then you return true, or you get left is equal to right, which this should be true, so you don't enter, or rather this will be false. So this the v left should be true, v right should be true when they're equal, and these will be false. Like assuming that that you have that character, and then this is for odd numbered palindromes, the middle character, and you say they're equal and they're equal to each other here, and then once you go once they're equal to each other, so that's a good question. This actually you could be stuck in an infinite loop here because this will keep iterating. These won't modify left and right. So once left is equal to right, then you actually would exit, I think, this loop. Yeah. Because when left and right are equal, then these two things are necessarily equal anyway, so it doesn't really matter. So, yeah. Yeah, okay, we gotta do it this way. All right. A little confusing, but yeah, we're gonna use the state we're gonna use to sort of show each subsequence is gonna be this Boolean vector, and I don't know if this is the best way to do this. Again, I'm actually really not sure about this. This definitely needs to be quadratic and not. This is going to be an exponential time algorithm if we do it this way. I think I need to rethink how I'm doing this, but I want to say basically we recurse on either we include the character or we don't include the character. And we have an index as well. Also would be part of the state. And we would say something like this. I don't know. Yeah, I don't know about this. This is definitely. Yeah, okay. So if current index is greater than or equal to s.size, return. That's base case. And then DFS approach. So really there's two children. So current index will be plus equals 1. And then subtract equals 1. You do f of really f. And you also say state dot set. You're going to set the bit, so it's going to be state of current index equal to true, and then set it back to false. Yeah, so process node, or just process, yeah, current state. We're going to say if palindromic of our state, then we're going to say ret equals standard max of ret and state. We also want to count the number of true values that are in the state. It's another kind of overhead. Just do auto. I don't know what to call this. Just add. So we're going to say int total accumulate state.begin, state.end, 0, and then add, and then we're going to use total plus to be a const. It's actually going to be a bool. The boolean converted to an integer. So we accumulate the total number of characters in this state, and we say total, right? So it's palindromic, okay. And then, so we process the state, and then we're going to increment the index. Now I think you have two situations here. You don't increment the index. I think in both cases we're incrementing the index though. I'm wondering if you do have a lot of overlap if you do this too, by the way. You either choose to add the element or you don't. And the tricky thing here is you want to increment the index at each point. There's a lot of redundant work here. That's actually what I want to say. There's a lot of redundancy. Yeah, I think the current index actually starts off at -1. And then you say increment the current index, set this to true, recurse, set this to false, decrement the index. Going to increment the index again. In this case, you actually set this to false and set it back to true. Excuse me, you take whatever it was. Well, yeah, you set it doesn't matter what it was. You set it to true, and then you set it back. So this is kind of tricky too. You actually save the state. So bool save state equals state current index. And then you set this to true, and then you set this back to the save state. And then you do the same thing again here. Save state equals state current index, which is the same, actually stays the same state. Set this to false, and then set this back to the save state. So that's a tricky thing. Incrementing and decrementing the index. Oh, actually, yeah. So also you decrement the index here. Otherwise, things get a bit funky. So increment the index, get the save state, set that state to true, recurse, decrement the index. Not yet, actually. Return the save state, and then decrement the index. That's the correct way to do it. And then increment the index. Oops. Again. Save the state. Set that save state to false, then restore the save state, and decrement the index. I realize it's there's a lot going on there, but that's basically kind of how you would do the DFS I think on all of these tests, if we make small test cases, this should be able to function properly. So now there's some redundancy here, right? Obviously this index, this is redundant, and this is also redundant. You're setting this back to the save state, and then saving the save state again, which is what you just set it to, so you don't actually have to set this back. You don't need to set this to the save state either, do you? Because you're going to set it to false anyway. So you only need to do the save state down here once. Save it once, and then true, recurse, false, recurse, set this back to whatever it was. What do we get if we run this? False. Okay. Interesting. Really? I wasn't expecting that. Output is 4. This also was way more confusing than I thought it was going to be. I thought this was going to be a little bit easier to code. Like, this is kind of a simple concept in theory, but for whatever reason I struggled with this. Why is this not correct though? Does this ever return true? That's the thing I'm wondering. I wonder if this is written incorrectly. This doesn't need to be here. Maybe that's wrong. No. Huh. I mean, I think this never returns true. I think that's the problem we're having here. That's my guess. Yeah. Okay. Excuse me. Oh, I think it's not supposed to be an and. Well, if this left is left is less than right, and not v left, so false. Okay. And left is less than right, and v right is false. So how come? Why? Like this should be true immediately, right? I think I know. I think I might know what's happening here. Yeah, I think I know what's happening. Also, looping over. I don't have any loops here, or not raw loops. Yeah, when you loop over a vector, you're supposed to use size underscore t for your type of index. I think what's happening here is that this is a signed integer being compared to an unsigned integer, and this always returns. I don't know if that's undefined behavior or not. I actually don't know. Test 2, test 3, yeah. This is greater than or equal to s.size. Oh, that's interesting. That doesn't happen very often. That doesn't happen very often. Because I think this has to be upgraded to a unsigned integer, and then it does type conversion, and then it becomes a -1, which is actually underflows to the largest positive. Oh, that's super interesting. That is super interesting. You don't see that too often, but I think I understand what's happening. The problem with that though is I don't know how I would do the initial execution of this. Like I guess I can convert this to an integer, do it this way. It's not really the correct way to do this, but we could try this, just see what happens. Time limit exceeded. Ooh, okay. Whoa. Whoa. That doesn't seem correct. What if you just had A? I think these aren't. I think it's getting stuck in here. These should all exit though. I guess if you're less than or equal to, then you would want to move over. I think you need to have these less than or equal to. That might be the problem. No. It's almost certainly one of these loops that this is getting stuck in. I don't think it's down here. I think that these loops will exit this loop. This loop is really kind of funky, so I don't think it's kind of strange. I don't think it's gonna necessarily exit. Yeah, that's right. What's going on? Okay. I would do it on time. Hour and 15 minutes. Okay. Left 0, right 4, left 0, right 4, left 0, right 4, left 0, right 1. So, excuse me. That's really weird. So, this 0, 4 shows up 1, 2, 3 times. Is that the problem? Is the typo? No. I think it may have been something I added when I was poking around here. So this gets stuck in an infinite loop. Somehow we go from 4 to 0 or 4 to 1. I want to say that's if we have a character in the first character, I guess the last character, and also the second character, something like that. Excuse me. For those 3 characters, while left is less than right. So we have 0 and 1. So this is true, but left is 0. If it's false, increment left. But let's suppose it's true, so we would leave it there. The right side, left 1, if this is true on this part, you would leave the right spot where it is. Oh, I see. So if they're less than each other and they're not equal, then you return false. But the thing that we're missing is when they are equal to each other, one of them needs to move. I think that's the problem. Excuse me. Yeah. Whoops. Yeah, I think you need to increment the left side here and decrement the right side. Right, assuming they both. Oh, yeah. Okay. 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 I didn't really think about that. This, by the way, becomes a for loop. Under these conditions, this is a for loop, where you scroll your left and your right values to the next. Scroll your next left and right values to the right spots. Excuse me. Left and right values, yeah, to the next possible character if it's there. So, if it exists. Excuse me. So, okay. So this appears to be correct, and it's not the most efficient thing though. If we start using more and more characters, you'll see it's not. This is exponential time. So it's pretty quick on a few characters, but once you start adding characters, it starts to slow down a lot. 36 milliseconds, okay, what's ahead? Now that we're gonna have potentially 1,000 characters, so this is gonna be quite the string here. This I think will TLE. This is a lot more characters, maybe like 100 or 200 characters. I don't think it's 1,000, but it's quite a few. Yeah, there we go, okay. So in order to get this to not TLE, I believe we can memoize this because the state itself. Yeah, I believe we can memoize this, and I think the state itself. We visit this state multiple times. even though there are an exponential number of states, what you can do is you can call this function and get a value for a given. How do we do this actually? I don't know. I'm actually not sure. So somehow we can take this. I think we can memoize it, but I don't exactly know how. Excuse me. I want to say there's some relationship between these different states, and so you don't need. You can. In this case, it would actually be pruning the tree, right? Like we don't actually need to look through all of the states, all of the possible states. That's what I'm looking for. Some kind of a way to prune this. I know we can do something with maximums, I think. Excuse me. Like we can return for this index, for a given index value, we can return the maximum of these two executions, right? Not sure what that would look like though. Excuse me. Also, I think you can return here. Oh no, I'm sorry, no, you don't return there. That's a mistake. This won't be right. Yeah. Let's be efficient, but it won't be right. Or be fast, but it won't be correct. What are we looking for? Excuse me. There are a few things to think about here, a few things to consider. So, one thing is, I gotta yawn again. Oh, excuse me. There are a lot of things to consider. So there could be a totally different algorithm here that could be used, but I think a dynamic programming solution is probably reasonable. But I want to say there's a recursive way of doing this where I think the problem is that it's not obvious what the relationship between each of these executions might be. Like we can move parts of the state into parameters here. So like the current index could actually just be a parameter that we give to call this function, and then you can memoize on that parameter. However, the issue really is that you'd be memoizing on the state too. Like you can move both of these parameters into the index and the state. You actually don't really care well, see, that's the thing. Like this does have some overlap in that you can consider you could consider the largest palindromic subsequence without the first character, and then without the first and second character, without the third character. Like, basically, those are sub-problems of the same problem, but just with one less character. I think that's the dynamic programming part. And palindrome of just one character. Excuse me. Oh boy. Palindrome of just one character is size 1. Obviously 0 characters is 0. 2 characters, it's not as simple as just considering the first character and the second character, though. Like, I guess the question you'd have to ask is, does adding this character increase a palindromic subsequence? Adding only one character won't do that, right? So actually, you don't need to consider. Well, yeah, you would do 2 characters at a time, I guess. But the thing about that is, if you're adding the character on the left side, or to the front rather, unless you're adding the same character twice to the front, you're not adding any new characters. I guess there might be characters that you could consider later down in the sequence that you might want to use. That's why I'm thinking maybe there's like not even a dynamic programming solution, but like a stack-based solution that you might want, because the order matters here, and that kind of makes things challenging. But this is a brute force approach, at least. So we have something that works that's brute force. What did I do to make this not work? Oh yeah, I put return value there. Yeah, we have a brute force solution. It's not correct. It's not fast enough, but it's at least correct. I think you can skip right into a linear or I want to say there's a quadratic time solution to this, the dynamic programming solution. But what's interesting is that it doesn't seem obvious here. Yeah. Maybe we can do a linear time stack-based solution. I don't know if I should even try that, but I guess we could. So I guess you could go like from left to right. You have a pointer on the left side, a pointer on the right side, and you say, okay, or maybe there's another way of doing this. Like you could start 2 pointers at the center of some character. Well, maybe, yeah, I don't know. Okay, let's do it this way. Let's say we have the longest palindromic subsequence from left to right, but definitely including the character at index I, right? Then our result is going to be the maximum of all of those palindromic sequences. Okay, that's true. It's definitely true. But how can we generate those palindromic sequences? Well, and can we do that? Can we generate them efficiently from previous information? Like, can we do this in a way that's inductive? Use induction to kind of do things more efficiently. Maybe, I don't know. How are we doing on time? Hour and a half, okay. So what did I say? I said it's palindromic. Induction. Right, if you found the largest subsequence that contains that particular character, or starts at that character, right? So all the palindromic sequences, subsequences that start at this character, and I guess could end wherever. So palindromic sequence that starts at a certain index of size 1 is just itself. That starts and ends with, that has 2 characters would be, well, 2 characters, I mean, I guess from there it's the largest subsequence then that ends from left to right, that ends at some index j. So there's an index I, index j, the largest palindromic subsequence over that range. Those are all technically subproblems. If you could solve them all in quadratic time, you'd have or solve them all efficiently, let's say in constant time, then you have a quadratic time solution. Yeah, well, I mean, this is the maximum. I guess this is sort of recursive. You could sort of make a recursive program that if you take all of the maximum subsequence, take all of the subsequence palindromic subsequences. There's a quadratic number of them, not subsequences, but consecutive sequences. There's a quadratic number of consecutive subsequences. Consecutive subsequences, and then you take the maximum palindromic subsequence of each of those subproblems. That's also the solution to the initial problem, the main problem. However, each of those have, consecutive subsequences, I guess. But I think, yeah, it's recur. It's like infinite recursion or something. I don't know. I don't know how long that would take either. I don't know. You would want to memoize that. I mean, you can, if you memoize that solution, that would be probably quadratic time with quadratic space. But that's also like a really funny kind of a problem. I don't know. The base cases are no, that doesn't work, because the base cases would be 0 if the well, if it's a single character, then it's size 1, right? For that subsequence. But if you have 2 characters, what are you supposed to do? Like, there's no way of handling. There's no way of handling the cases that have more than 1 character. It's not a base case, but it's sort of the inductive step. We don't actually have an inductive step. I have some idea, but not a full thought yet. How are we doing on time? All right, hour and a half, a little bit over an hour, a little bit over an hour and a half. Can you help me? Hello, Mega XD. Hope your day's going well. Welcome, welcome. I don't know. Maybe. I'm definitely a little bit preoccupied at the moment, though. I might be able to help you, but I probably would have to finish this problem and then try to help you, because unless it's like a super easy thing, yeah, because I probably should finish the problem first. But well, yeah, what do you need help with? What do you need help with? If it's something I can help you with, I could try. If it takes me just a few moments, but if it takes me longer than that, then I probably will have to give up and return to the problem. Give me, oh my, you're gonna hear a noise on the headset, by the way. It's gonna be annoying, but I need to charge the headset or it's gonna die. I don't have a solution to this problem, man. I'm just kind of guessing. I'm just kind of guessing. Yeah. So, how would we do this for 3 characters? Like, how would we just do this in the simplest case? How could we do this? Well, if they're all different characters, then it's just 1 is the answer. If you have at least 2 of the same characters somewhere, then you have 2. If you have 3, actually, if you have a palindrome of size 3, so the thing that's interesting is these are subsequences. So as long as you have, if you have 2 characters, like it's got to be, it's sort of like nested, I guess. If you were, I'm not sure how to express it, but you insert a character, insert a character, insert a character, insert a character, and then the character that you're about to insert is equal to the character that you have at the top of the stack, then you could pop those, and you could pop all your elements down. The thing that's tricky about doing it that way, though, that's, I guess, one way of determining if a sequence is palindromic. But the thing that's tricky about that is oh man, what's going on with my face? I think I have my skin's got something going on there. The thing that's tricky about that is you could pop too soon. Like, you could have A 3 times, and you have push on A, and then you pop an A. And you would actually want to not pop the middle A, not pop the middle A, or you have 4 A's in a row. So stack-based kind of approach may not be the best. You can use 2 pointers at least, and just say, kind of move them to each other and check. But but 3 characters, how would we do this problem with 3 characters as our target? Well, clearly the first character is a palindrome of at least size 1. The second, if we have a second character, if it's a different character, then we may or may not have a palindrome of size 2. If it's the same character, then we have a palindrome of size 2. And the next character, it's again the same character, we have this palindrome of size 3. If that character matches the first character, we have palindrome of size 2. Well, actually, a palindrome of size 3. If it matches the second character, then it's a palindrome of size 2. I don't know. Those are kind of all the different situations, I guess. Depends on, I guess, how each character is related to each other. Well, you only have size 3 if the first and last character are the same, right? I think I could say that, because if they're not the same, then even if the middle character is equal to one or the other, then the best you can do is have size 2 for your palindrome. I think so. So now let's consider. Yeah, so that gives you size 3. So but maybe you have size 2. Size 2, you would need to have the middle characters equal to one of the other 2 characters. And then size 1 is always the case, as long as you have at least one character, which we have 3. So I'm trying to figure out a way if there's like some way we can do this where there are sub problems to consider somehow, but I don't think so. I think actually this problem is kind of challenging, but I don't think that's necessarily the way to do it. So if you had 4 characters, then you would say, okay, the only way we can have 4 is if the whole thing is a palindrome. Yeah. Otherwise, we have less than 4, right? To have 3, you have palindrome but missing one character. Almost a palindrome. Delete one character and the whole thing's a palindrome. To have 2, delete 2 characters and you have a palindrome. To get one, you delete 3 things and you have a palindrome, which is always true. You can always do that. You can always delete n-1. So really, another way to understand this question is, if the current string is not a palindrome, how many characters are required to be deleted in order to make this palindrome, in order to restore the palindromic property? That's actually probably the way to look at it, because I think if you look at it that way, then this has a much better, it's a much simpler way to approach it. So it's pretty straightforward. You just delete A and you get palindrome size 4. For C, B, B, D, you would delete C and D. What about something like ABAB? Well, ABA is palindromic and BAB is palindromic, but clearly ABAB is not. I could think of a cubic solution. No, that's not cubic. No, never mind. But basically, I would want to say, like, for each possible length, see if you could find a palindromic subsequence of that length. Given the string, but I don't think that's really helps us that much to do it that way. Obviously, size 1, as long as you have at least one character, it works. Size 2, you need to find 2 of the same characters. Size 3, you would need to find 2 of the same characters with a character in between. Size 4, you'd find 2 of the same characters with another set of characters that are the same, that are between those 2, sort of nested. So you can do a set of size 4 be a set of size 2 nested within a set of size 2. another set of size 2. I guess maybe that's the way to do it. So you can do all of the even values would be sets of size 2, nested sets of size 2, and then the odd values would be similarly sets of nested sets of size 2, except also kind of around a focal point, single element focal point. The thing that's tricky about that though is that like you could have multiple possibilities for your sets, meaning like you could have like A, B, A, B, A, B, a whole bunch of different sequences of A's and B's, where around a certain focal point you could have like the two closer A values, but if you pick those, then it would be more challenging to pick the two B values, so you'd want to pick actually a slightly further away A value so you can get two B values. Something like something that might look like this. Like I was saying ABA, right? And you'd have two A values, but you'd want to pick the further A value so you can include the B's. So you do B, BB, AA to get you 5. That makes sense. So B, 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 and then the two A's. And that gives you a palindrome size 5, whereas I mean you do A here too, and do A, B, B, and then A. Yeah. Not sure if that really matters, but you probably could use different characters here to kind of get the idea. But you wouldn't want to pick like the most immediately, I guess the immediately closest pair. I suppose, maybe I'm wrong. You could pick a center of size 1 or size 2. And sort of build outwards from there. So size 1, you can't really build out the string too much. So it's just size 1 for that. And then size 2 here, the starting index. So I guess at each index you have a starting size of size 1 or 0 or 2, and then you can kind of build out the largest subsequence from there by appending values on the left or the right. So A, you would get just A. AB is not a palindrome. Then you have B. You can add A and A, you get 3. BB, you can also add A and A, but that's about as well as you can go, as far as you can go, so you get 3 and 4. B, you can do A, B, A, that's as well as you can do. Yeah, B, 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 you can do. The thing that's tricky about that though is like you're kind of stuck with this similar problem where do you include this or do you not include this character, and you have to make that decision, because if you include, you can get all 5. So you can do B and you include the first B on the right, and then you have A and you include the first A on the right. But I want to say something like if you include the first B, then the first B on the right, but there's maybe another B. I don't know. I'm trying to think of a counterexample where you wouldn't include the first value from the left or the right. I don't know. This is a challenging question. I don't know the answer. answer. I have to kind of really think about it. I think as long as I can do quadratic time, then we're okay. If you do A, B, B, A, B, yeah, I mean, if you do 1, and then you say 1 and 2, but then you can't include the A, right? Whereas you wouldn't necessarily do better if you include include this A and this A. Excuse me. I guess what I want to show is it always better to, and it kind of doesn't matter what the center is, but is it always better to pick? So you have a character on the left side that you select, and you loop on the right side to find the first character that matches in the subsequence. Is it always better to pick the first one? Well, not necessarily, right? Because yeah, that's exactly correct. So it's not necessarily better to pick the first one. If we did, well, let's do something else. Let's do like a few different things, right? Well, let's do C. So let's say C is the focal point or the midpoint that we're looking at, and we want to say, excuse me, we see B, and we have an A over here. We want to include this A. There's another A there. If you look at the B, the first B on the left, you take the B on the right, and then you can pick this A and pick this A. But I want to say something like, if maybe there's a further X, Y, Z, I don't know, further B. If we pick the later B, I don't know. I'm not sure how to. I don't know. I don't know. But there is some test case I'm thinking of in my mind that seems to work, but when I'm trying to write it, doesn't seem to work. Let me try again. So is it always true that you see a character to the left, you want to take the first character to the right that matches, if it exists? If it doesn't exist, then there's no point in you just moving the next character anyway. But if it does exist, you want to take that character. So there's a, let's say there's an X on the left, so you have A, X, dot, X, and then dot, X again. And so you'd always want to take this X. Yeah, that's always true. Because, I mean, you could have BB over here and BB here. So this is the case that I'm thinking of, the counterexample. Because you took this X, you can't take these B's. And actually you would do better if you skipped this X and took these two B's. That's what I'm trying to say. Yeah. And that's basically the crux of the problem, I think. Now, how do you know which things to skip and which things to not skip? Kind of don't, do you? Palindromic subsequence is basically like the most nesting of these pairs. I think I'm going to lay down and ponder it some more. I don't really have an answer here. I don't know. Tough question. I want to say, like I said, I think there's a dynamic programming solution that we can use, but I just don't have it offhand. Cannot seem to think of it. Oh, okay. I gotta think about this some more here. Oh, it's cold in here. We gotta eat something. Excuse me. Oh boy. Okay. Hoo-wee. Hoo-wee. How do we solve this, man? I don't know. 3, 4. How would I do it for 4? Like if you had A, B, C, D, it'd just be 1. You could throw an A somewhere in there. You get 2. Yeah, the tricky thing is like the order of the subsequences matter. Like if you could rearrange the subsequences, then you can just take the like a frequency map and take all the pairs, right? Take everything that's all the 2s. But that's not quite good enough, right? It's actually not it's not rearranging the characters however you want to make the palindrome. It's actually only basically deleting characters to make palindromes. Well, how many different ways can you delete characters? An exponential number. Right? There's a lot of different ways you can delete characters. Yeah, we're looking for rules to prune our tree, our depth first search that goes through an exponential number of possibilities. We want to prune that so we don't need to go through so many possibilities. It's kind of the crux of the problem, the crux of the question. But how? How can we do that? I think from that focal point, well, you can kind of grow. Excuse me. Actually, I'm wondering if this is at all related to the subset problem that we were looking at earlier, which was adding numbers to get to a certain value. Yeah, how many different ways can you add? How many different ways can you add numbers together to get a certain target value? It's kind of similar. I don't think so. No, it's not similar. It's similar in that you're looking at subsets, right? but it's not subsets that we're looking at. We're actually looking at subsequences, which are subsets, but they're not. They're subsets of indices. That's what it is. Yeah. So we're looking at subsets of an index, of like a set of indices, and trying to get the subsets that are not equal to a target, but they have certain properties, I guess. So that's why I'm thinking. That's why I'm thinking this is related. I think this is a kind of a dynamic programming solution that's related to subsets. Yeah, interesting. So we're looking for subsets that are subsets of the indices, such that when read left to right, it would be or read if it's reversed, if it's read left to right and right to left, it's equal. The indices, if you evaluate them, they're characters. If you read it left to right, the evaluation, right, they're mapped to strings and the characters in the string. Reading them off left to right is equal to reading them off right to left. Yeah. That's the property we want our subset to have, whereas the previous question, the subset sum, the property that we want is that the subset sum is equal to the target. And the way we did that is we would subtract. I want to say that there's an analog here. No, it's not quite the same. I mean, we're doing something with subsets, but there's like a very clear thing you can do with subset sums, in that you can for each integer that you're considering, you can subtract through an array, or rather add to an array. In other words, you can kind of solve like a series of sub-problems where you can say, well, the number of ways you can get to a particular integer, a target integer, if you're using just one value, would be adding that value, and then obviously all the other possibilities don't change. But then if you can add another value, then it would be basically all of the other, it would be the sum minus that value, that target. You can get there however many ways you can get to the how do you express it. So like if there's a target x and then there's some value v2, we'll call it v sub 2, then the number of ways you can get to x minus v sub 2 using all the other values you've considered so far, you can add that to the number of ways that you can get to x sub vx, yeah, because you can add v sub 2 to all of those, or v sub I really it would be. Give you all those possible ways you can just add v sub I, and that will get you to x. So however many ways you can currently get to x, you just increment that by x minus v sub I, and you do that for every integer, and that's it. But well, yeah, I guess there is something of an analog where you could say the number of ways. Well, we don't really care how many ways you can get to a certain palindrome size. We only care that you can get to a certain size. So I guess it's one less dimension we have to worry about.
sort of, but well, it's similar in that it's are there any ways to get to a particular palindrome length? Well, I mean, you might say something like, you can maybe loop over I and j, so how many characters sort of you already looked at in a certain sequence, and then you would say from a particular I and j, you can process each of the characters from left to right. So you could say, like before I was saying there's an X and there's a BB. You could say, okay, if we take X, then we can get to a certain subsequence length at a particular for a particular I and j for a particular I and j. But then if we don't take X and we take B, then we can get to another I and j, I guess. And we take another B, then we get to another I and j. But I actually don't know. Now I'm thinking about it. Yeah, kind of a greedy approach doesn't really work. Or not a greedy approach, but I don't know. We're definitely dealing with a subset problem, though. That's something that we have to kind of recognize. Excuse me. Oh boy, I don't know. I'm not seeing it. I don't know, I'm stuck. Also, my mind's kind of wandering. Let me just continue to ponder, I suppose. So there's a few things that are interesting about this question. First, the number of characters that could be in the string was only 20. There are only 26 of them, so it kind of makes the problem a little bit easier in some sense, possibly, maybe, because there's only 26 different characters. So you're guaranteed to have a certain amount of repeating after a certain point. And that's related to the palindromes. Excuse me, because you're really looking for pairs of values. And so let's make the problem a little bit easier. Let's consider only strings with A's and B's. And then we realize we count all the A's and count all the B's. There are lots of different pairs of A's and B's. And actually, if you took all of the A's, let's take a relatively long string. Let's say it's like, a couple hundred, or like 100 characters, let's say. All of the A's, you can actually make a palindrome centered around all of the A's. If there's an even number of them, you just make the palindrome all the A's straight across, and then half of those A's, half of that number is actually, yeah, that's the length of the palindrome. It's just all of the A's. And same thing for B's. You could do all of the B's. The length of the palindrome is all the B's. So you always have at least a minimum length for your palindrome based off of the however many number of each character there are. Now, what's interesting is that there may be some overlap where you could include some of the A's and the B's together, and you get something longer than either just the A's or just the B's. Which is kind of what I want to go for. Maybe, hopefully I can get something doing it that way. So it's like A, B, A, B, A, B. If you just had A, B repeated a whole bunch of times, really that whole thing would be a palindrome except one character. One of the A's or one of the B's you would exclude, but B, A, B, A, B, A, B all the way down would also work. So would A, B, A, B, A, B, A, B, A, B, A. Centered around an A or centered around a B. Centered around an A or centered around a B. I guess what the problem you might run into is that you could have sort of distortion where you have like a few A's and then a few B's, and it doesn't really match on the other side of the string, something like that, like a random amount of A's and B's. Well, excuse me, I don't know. Like, let's say we had just all the A's on one side and all the B's on the other. So all A's and then all B's. There's no real overlap then, and that palindrome doesn't work. Or I mean, you get sort of two different possible palindromes, but in the A and B is, yeah, there's no overlap. So A is the best or B is the best. You have to pick one or the other. Okay. Not sure how you could make that distinction necessarily, but whatever algorithm we come up with has to take that into account also. Still trying to ponder this here. Let's say they're both the same size, but we have one A and one B right in the middle. They swap with each other. So instead of A being right next to B, instead of all the A's being all to the left and all the B's to the right, let's say you have just one A shifted over. So you have all the A's, almost all the A's, a B, the last A, and then all the B's to the right. What would the largest palindrome sequence be for that? Well, can you include the B at all? I don't think so, because if you include the last B or the last A, or the last A on the right or the last B on the left, if you try to make a subsequence, palindromic subsequence out of that, then you would have A, B, A, and then all B's to the right, but there are only A's to the left, the leftmost of A. And the same thing on the other side, if you try to do, B, A, B, we have B from the left, so B, A, B, and then there's only A's to the left and B's to the right, so that only gives you 3 for each of those, and then those sequences are not as long as the, presumably, right, assuming we have like 100 A's and 100 B's. So there's some overlap there, but not really enough. Now, what's also interesting is that you could have a lot more overlap where they completely overlap. So you'd have a palindrome of all A's, and then on the left and the right side would be all B's. So the whole thing's a big palindrome. Um, I'm gonna charge the headset while I'm sitting here laying down thinking. I don't know, man. I don't have a solution. I don't know. I don't know. I don't know.
So I'm still pondering this question. I don't have a good solution. Do not. Thought maybe some kind of a recursive solution I could just memorize and that would be that, but I don't think so. I don't think it's gonna be that easy with this one. Alrighty, now this is a good question. Alright, so basically, I think what I'm going to do here is end it here. Excuse me. Make this part 1. Start the stream again with a part 2. I have a possible solution. I think I want to do it that way. Yeah. You know what I want to do? I want to code up this solution, end the stream, go to the bathroom, and probably come back to this, take a look at the discussion. I kind of want to get food also, but I have an idea for this, by the way. I have an idea. Yeah. Okay, let's do this. So the idea goes like this. It's actually quadratic time, the solution, and it's not, there's no memory that's used. Well, there's some memory. There's a stack, so it's linear memory, I guess, or potentially quadratic memory, I suppose. So we're going to use recursion, and it's going to go like this. We're going to have 2 integers, left and right. And we're going to call for each character well, you could do it this way. A C is less than or equal to Z plus C, right? Going to say we're going to call it recurse 0 s dot size minus 1 of recurse. We're actually going to return this, and what we are going to say is, actually I don't know if this needs to be memoized or not. I don't think so. I don't think it matters. We're gonna have a base case. I don't know if we need to do this, but we're gonna memorize it anyway. Okay, so we're gonna do this is the basis for the idea. It goes like this. If there is a maximum palindromic sequence, then either it's one of these base cases, it's 1 character or 0 characters, or it's flanked by 2 characters. Yeah, or it's flanked by 2 characters, right? So if it has 1 character, it's not flanked by 2 characters. If it's 0 characters, it's not flanked by 2 characters. But if it's only 2 characters, that it would have to be the 2 same characters. And so every solution is going to be flanked by 2 characters, which means there's a sub solution that if you sort of consider, if left is the left side of that flanking character and right is the right side of that flanking character, those 2 indices into the array or into the string, if you take left plus 1 and right minus 1, if you take the maximum possible subsequence of that recursive case, then add the 2 flanking characters, then you have a larger solution. So the largest solution has to be has to be of that form, that it's basically the largest subsequence. It's the largest subsequence. Excuse me. It's the largest solution with two flanking characters appended. Okay. There's only 26 different characters to consider, so we can find the largest possible flanking characters. And from what we just argued, it's must be the case that the largest possible solution has to have at least one of these flanking characters has to be part of that largest solution. And even though there could be multiple different like each of these flanking character pairs that we select, we can guarantee that the ones we want to consider are always going to be the leftmost for a given character is the first leftmost character. It's the first leftmost character and the first right, or the rightmost character and the rightmost character and the leftmost character in the string, because there could be multiple different characters to consider. However, there's always going to be a leftmost and a rightmost if there's at least two characters. So that's going to be the approach. Kind of an interesting way of doing it, but I think it's correct. So we're going to say from left to right. So we'll say find leftmost character in the string. It's going to start off at left. And we're going to say while s of leftmost is not equal to, so we're going to say while left, and we're going to say no pair equals false. While leftmost is less than s.size, and leftmost is not equal to C, we're going to increase leftmost. Leftmost, oh yeah, well actually, yeah, we don't have to do that. And int rightmost is equal to right, while rightmost is less than s.size, and s of rightmost is not equal to C. We're going to decrement rightmost. Okay. If leftmost, leftmost is greater than or equal to 0, or greater than 0. Leftmost is less than s.size, and rightmost is greater than or equal to 0. Then we have a possibility to consider. So we have ret equals 0. Turn ret. We do this recursively. And we're going to say ret equals standard max of, we're going to recurse on, it's going to be ret, and recurse on leftmost and rightmost. It's going to be leftmost plus 1, rightmost minus 1, yep, plus 2. Yeah. So we'll recurse on that case for each of these characters that we could select. Yeah, and I think this is quadratic time complexity, by the way. Yeah, because with each iteration, 26 times basically we remove at least 2 characters. So it's a constant factor of 26, I think. But we remove 2 characters at each iteration, and actually this could be it's a linear amount of time. Actually, it's not a linear amount of time because, excuse me, this actually might be linear overall, which would be weird. I wouldn't expect that, but let's see if it's correct. Let's see if it works. Let's start with that. See if it works. Compile error. Oh. Oh. Hold on. No, I did that wrong. Yeah. Okay. That should be correct now. We'll memoize this just for good measure. Also, TLE. Okay, maybe we do need to memoize this. I don't know what the time limit is on this. But that was efficient. Okay, it's not correct. It's not correct. Huh. Oh, that's why. Mixed up my commas and parentheses and things. Okay, very close though. I think it's linear, actually. I don't think this might be linear. Looks like we're correct on 4 and 2, but on the last 2 we're wrong. We're off by 1 character. We have 1 too many characters. No kidding, really. Huh. Should be 3 and 43. We got 4 and 44. Let's see. What if we remove this test case for now? I see something here. If we don't memoize this, what happens? Okay, so the memoization is fine. It's just this is an incorrect algorithm. Okay, what goes wrong? So Now, how did this give us 4 instead of 3? So we would do A, we'll go right off the edge, there's no other A. K, there's a K and a K. And there would be J, S, D, H, F. So there's no palindrome in there. So there would be, it'd be 3 here, K to K. A would go off, B would go nowhere, C would go nowhere. C, D would go nowhere, E would go nowhere, F would have something. No, F would go nowhere. C, D, E, F, G would go nowhere, H would go nowhere, I would go nowhere, J would have something, K would have something. So J should have 3 and K should have 3. A, B, C, D, F, G, H, I, J, K, L, M, N, O, P, Q, R, S. S would go nowhere, T would go nowhere, U would go nowhere, V would go nowhere, W, X, Y, and Z are not there. So really, this is the issue. So this is the crux of the problem, right? There's this KK and JJ, and somehow we end up with 4 instead of 3. So K and K would operate on this part, this J to F, which I think should give you 1, right? That's a question. J, S, D, H, F. Oh, that's a problem. Why do we get 2 there? Ooh. Right, that's wrong. Oh, I see. So red is initially 0. Huh. If we have A to Z, let's say A less than size. Okay. Oh. Shouldn't these all just be 0? Right, this should never execute. So close. I think I have the right idea. It's just not implemented correctly. Okay. Yeah, because okay, so this gets called a few times. This F should return 0 on everything. That's the problem. We're doing F plus 2. So D, F, H, J, and S. So D leftmost. Oh, because they're equal. That's why. So it's 0, and these will go past each other, which will give you 0, but that returns 2. And they're not equal to each other. There you go. That's why. Output 0, expected 1. Uh-oh. Uh-oh. Mhm. Well, ret is always going to be at least 1, I think. Yeah. I think we don't have to have this edge case ever, so that's the only time it would be 0, but otherwise it's always at least 1. There we go. So I think we're correct. I don't know how efficient this is though. I think this is, like I said, I think it's linear time. I think because each time you get, oh, still wrong. Okay. No. Say it ain't so. That's not correct. Okay. So this is still wrong, I think, even with a change. This doesn't need to be, well, actually, I don't know. I need to change how I do this. Okay. Excuse me. This might not be correct then. So as long as there is a pair of values to look at, then we're going to check against. We're going to run this recursive routine. Otherwise, we assume as long as left and right, yeah, as long as left is equal to right, then when you run this, it shouldn't, actually, I don't think you even need the space case. So, okay, great that we get 1 here, but then why do we get, if we did kj, what happens here? Why does that happen? I was not expecting that. What if we get rid of one of these j's? Okay, we still get 4. How do we get 4 there? If we remove the k's, okay, so somehow the second case, we have a k and a k, JSDHF. Somehow we get something really strange here. We don't need to memorize anything yet, I think. What is going on? So, what? Okay. Okay. Also, it's only 3 hours and 20 minutes. So K and K, oh, that's interesting. Oh, I end up calling this more than once, huh? How does that happen? So we call K, recurse leftmost, rightmost, leftmost, J, rightmost, F. Then we recurse on J, S, D, H, F. But why is, oh, actually, that's what I'm doing this wrong. I need to get rid of these. I'm sorry, it's getting really confusing because I'm trying to debug multiple things at the same time. Yeah, we'll just leave it. We don't need to do all that. So this one, we should just be looking at this. Okay, wrong answer, but no, but we do run K twice. Check on K happens twice. That shouldn't happen twice. This should only happen once. It should be, you see K, and you find the leftmost, find the rightmost, which they're in the same spots, and then you say it's less than, leftmost is less than size, rightmost is less than greater than equal to 0. They're not equal to each other. Say check, print C, and then you compare 1 to this recursive call. All the other ones, by the way, go off the edges or don't meet, so you don't have any other check. But now the leftmost should be 1, and the rightmost should be, so this should be J, and this should be F. And then you recurse. Now, this doesn't ever reach, right? So that's really bizarre. I'm a little confused, so it must be that I just programmed this incorrectly. I must be missing something important. Yeah, so I think somehow Oh, that's what I did. Okay, I got it. I know I did it wrong. Yeah, I programmed it wrong. Such a subtle thing. Kind of implicit is leftmost is less than size, and leftmost, and also leftmost is less than right. Of course, and rightmost is less than left is greater than, and rightmost is greater than left. Yeah, the leftmost is to the left, and the rightmost is to the right. You actually don't need this greater than equal to 0. Oh, duh. Okay. Yeah, I actually don't need this anymore either because they can't be equal to each other. Well, actually, no, they can end up being equal. How about that now? I think that's what I did wrong. Oh no. It's wrong. Uh-oh. No, oh man, why is this so hard? Why is it so difficult? Why is it so difficult? Oh man, come on. Now they're both, oh, come on, really? Now they're all incorrect. ABC runs into check. No! What is this now? What? I think it's less than or equal to. It's gotta be end. Well, Well, yeah. Okay. Let's try that. Okay. Just make sure this isn't contributing anything. Why is it so difficult to program? Seems so simple, yet such a challenge. So somehow, if we add this K and J in there, okay, we get a call for J, but then we get a call for A, B, C, and E? A, B, C, E, G, H. Once you get J, you do just S, D, H, F, K. So let's remove the K's, or let's remove the J's rather. What does this give us? This is driving me crazy, man. Okay, A, B, C, E. For some reason, D is not in there. I don't know, P, Q, R, T. Why S isn't there as well? Oh yeah, because D is, okay. So, now, come on. S, D, H, F, K. This is great. Okay. Leftmost is the left side, less than or equal to the right, and leftmost is not the character you're looking for, and then rightmost. So they can go past each other. That's the thing, right? Yeah, I think that's the issue. I think rightmost has to be less than leftmost. I think that actually is the problem. No, not the right. No, did that wrong. Leftmost is greater than rightmost. Okay, this is so confusing. This is so confusing. There we go. Of course. It doesn't work if they go past each other. Now, they're not supposed to go past each other. That's the other thing. Like, yeah. Yeah, even though, yeah, see, that's confusing. That's confusing as all heck. There's something of an optimization that has to happen here where, now it seems like, I think this is quadratic time, by the way. The reason being, even though you're moving, well, no, it's not actually quadratic time. No, it's quadratic. I think if I don't add this optimization here, I think it's linear because, yeah, I think because each time you run this, you basically remove all those characters that you iterate over. So leftmost is less than or equal to right, and then here, rightmost is greater than or equal to left, and rightmost is greater than or equal to leftmost. I think we add this optimization here as well. Okay, we can get rid of this check. All right, that seems very confusing, but I think, yeah, I probably would have got that wrong if I had. I mean, I definitely would have gotten that wrong in an interview. 100%. This would have been wrong. It's like, all right, we're correct. 3 milliseconds. Okay. So let's do something that does have 1,000 characters. Let's do, I don't know. Is there a way to count how many characters we have? Let's do this. Print new line word and byte counts. We want byte counts, bytes. So C bytes. 107. Okay. So we're gonna add something here that has 1,000 bytes, or 1,002 bytes. Got a while to go. Got hundreds of characters to go here. Here's the hoping that this is linear time. Still have like 400 characters to go. $200 more characters. Hopefully hit all the right keys. Oh no! Whew. Okay. 103, okay. I think we gotta get rid of one character. Okay, hopefully this will work. The test case will be valid. Invalid. Oh no. Some characters in there that are not 1,000 characters. Oh, there we go. There's one. There's one. Let me try again. Three and a half hours, okay. Hey, okay, 362 milliseconds for that one. I think it's quadratic. I think it's quadratic. It's relatively efficient, but yeah, it's okay. All right, let's go for it. Let's see how we do. Let's go for it. Hey, we got there. Sweet. Sweet. A lot less memory than most solutions. So I think there's probably a linear time solution. Pretty interesting. This is maybe not the best solution. It works, but it's definitely, yeah, kind of a questionable approach. Pretty sweet that we did well in the memory though. Yeah, I definitely wonder what the discussion has to say. We'll come back to this. Let's make this part 1, and then we'll make a part 2 where we go look in the discussion. But yeah, so thank you for watching. I'll talk to you soon. I'm going to go ahead and probably eat, use the bathroom, go to sleep, some variation of those things. But this is interesting, and I appreciate the conversation also with Venjot came by, said hello, appreciate that. I'm not sure, Mega XD asked for help, but never told me what he needed help with. So yeah, I'm gonna go. Thanks again for watching. Talk to you soon. Have a good rest of your day.